Welcome to this deep dive. We're going to be talking about John Henry Holland.
Yeah.
A true visionary, I think it's safe to say, in the world of AI.
Oh, absolutely.
You're interested in AI and
Great place to start.
this is a great place to start. Yeah. We've got some excerpts from an article about him.
Okay.
John Henry Holland, pioneer of genetic algorithms in AI.
Mm-hmm.
And it's really clear from this that this guy,
Right.
he wasn't just coding algorithms. He was inspired by nature itself.
Yeah, it's true.
Yeah.
What makes Holland so fascinating is that he was trained in physics and math.
Right.
But his interest spanned far beyond. That he was captivated by Darwinian evolution and cognitive psychology.
Uh-huh.
A unique blend that really shaped his approach to intelligent systems.
So not your typical computer scientist, then more like a Renaissance man,
Precisely.
Saw the connections between seemingly disparate fields.
Yeah, he was asking questions like, what if computers could learn and adapt like living organisms?
Mm-hmm.
That's a pretty revolutionary thought, especially back then.
Okay. I'm already intrigued.
Yeah.
Let's talk about these genetic algorithms.
Sure.
I'm guessing that's where the evolution part comes in.
Holland had this incredible insight.
Okay.
He realized that computational systems could be designed to evolve, just like populations in the natural world.
Okay.
Instead of programming a computer with every single step,
Right.
you create a system that can discover solutions on its own through a process that mirrors natural selection.
So it's like survival of the fittest, but for computer programs.
Yes.
How does that actually work?
So imagine you have a problem you want to solve, like finding the most efficient route for a delivery truck to make multiple stops.
Okay.
With genetic algorithms, you start with a population of potential solutions, each represented by a string of code.
Mm-hmm.
These are like the organisms in our digital world.
Okay. So each piece of code is like a different route the truck could take.
Exactly. And just like in nature, some routes will be better than others. They'll be fitter in the sense that they're shorter, faster, or more fuel efficient.
So how do you make these digital organisms evolve?
We use processes that mimic natural selection. There's selection, where the best performing solutions are chosen to reproduce.
Mm-hmm.
Then there's crossover, where parts of different solutions are combined, kind of like how genes are mixed during sexual reproduction.
Okay.
And finally, there's mutation, where random changes are introduced to the code, which can sometimes lead to unexpected improvements.
Hold on. It's like you're breeding computer programs.
Yeah.
But how do you even know which solutions are the fittest in the first place?
That depends on the problem you're trying to solve.
Okay.
For our delivery truck example, you might have a program that calculates the total distance or time for each route.
Right.
The shorter and faster routes would be considered fitter, and they'd be more likely to be selected for reproduction and contribute to the next generation of solutions.
And by repeating this process over many generations, you eventually end up with a really good solution.
Exactly. It's a process of continual improvement.
Yeah.
What's remarkable is that genetic algorithms can tackle problems that would be impossible for humans to solve manually.
Right.
One early example was the traveling salesman problem, where you have to find the shortest possible route that visits multiple cities and returns to the starting point.
Oh, wow. I remember hearing about that the number of possible routes explodes as you add more cities.
Absolutely. It quickly becomes computationally intractable to try every single combination.
Yeah.
But genetic algorithms can efficiently navigate that vast solution space, finding near-optimal routes without having to brute force their way through every possibility.
So by tapping into the power of evolution,
Yeah,
Holland's algorithms could solve problems that would otherwise be computationally impossible.
that's right.
That's incredible, and this was just the beginning of his work, right?
It was.
Didn't he also delve into something called complex adaptive systems?
He did.
Yeah.
And that's where things get even more fascinating. But first,
Okay.
we'll take a quick break.
Okay, sounds good.
Be right back.
All right. So tell me about these complex adaptive systems.
Yeah, so think about an ant colony.
Okay.
Each individual ant follows simple rules, yet together they create this incredibly complex and sophisticated society, able to find food, build intricate nests, and even defend themselves against threats. That's a classic example of a complex adaptive system, or CAS.
Right, I see. It's like the whole is greater than the sum of its parts. But how does this relate to AI? Are you suggesting we build AI systems that act like ants?
Not exactly like ants, but the principles are similar.
How-
Holland saw the potential of creating AI systems where simple agents following local rules could interact to produce emergent behavior. Imagine a network of self-driving cars, for instance.
Okay, I'm picturing a futuristic city where these cars are constantly communicating with each other.
Exactly. Each car is making decisions based on its immediate surroundings and its programmed rules. But the interactions between all these cars on the road could lead to a more efficient and safer traffic flow overall. That's emergent behavior.
Wow, so it's like a collective intelligence where the system as a whole can solve problems that no single car could on its own.
Precisely. And this idea extends far beyond self-driving cars. Holland's work on CAS has influenced fields like economics, where researchers use simulations to understand how markets behave. They can model things like the stock market or the housing market as complex systems, with individual agents making decisions based on their own preferences and limitations.
So instead of trying to predict the exact actions of every single trader or homeowner,
Right.
you're looking for the emergent patterns that arise from their interactions. That's pretty insightful.
It is, and it allows researchers to test different economic policies or scenarios and see how they might impact the system as a whole.
It sounds like Holland's work has had a ripple effect across so many different fields, but his biggest impact might be on how we think about intelligence itself, right?
That's a key point. Holland's work challenged the traditional view of intelligence as something that's purely computational or rule-based. He saw intelligence as an emergent property, something that arises from the interactions of simpler components. Think about the human brain, for example.
Okay, so our brains are made up of billions of neurons, each following relatively simple rules.
Right. And it's the connections and interactions between these neurons that give rise to our thoughts, feelings, and behaviors. We don't have some central intelligence module in our brains. It's a distributed dynamic process.
That's a fascinating concept. It makes you wonder if consciousness itself is an emergent property, something that arises from the complexity of our neural networks.
That's a big question, and one that continues to be debated. But Holland's work certainly opened up new ways of thinking about these fundamental concepts.
And speaking of opening up new possibilities, I have to ask about swarm intelligence. Isn't that another area where Holland's ideas have had a significant impact?
Absolutely. Swarm intelligence is essentially CAS in action, specifically within the realm of AI. It draws inspiration from swarms in nature like flocks of birds or schools of fish, where individuals follow simple rules but collectively exhibit complex and coordinated behavior.
So instead of building one super intelligent robot, you have a bunch of simpler robots working together, kind of like a hive mind.
Exactly. And this approach has a lot of practical applications. For example, in disaster response, you could deploy a swarm of drones to search a large area quickly and efficiently, with each drone communicating and coordinating its movements with the others.
That's a pretty cool application. What other areas are using swarm intelligence?
Well, it's also being used in fields like logistics and manufacturing, where swarms of robots can work together to assemble products or move goods around a warehouse. And there's even research being done on using swarm intelligence for medical diagnoses, where tiny nanobots could work together to identify and target cancerous cells within the body.
Wow, the possibilities seem endless. But with all this talk of intelligent machines and emergent behavior, I can't help but think about the ethical implications. Is there a risk that these systems could become too complex or unpredictable?
That's a valid concern, and it's something that Holland himself was acutely aware of. He believed that as we create increasingly sophisticated AI systems, we need to be mindful of their potential impact on society.
So it's not just about building intelligent machines, it's about building them responsibly and ensuring they align with our values.
Precisely. We need to consider things like transparency, accountability, and control. How can we ensure that these systems remain aligned with human goals and don't pose unintended risks?
Those are big questions. And it sounds like Holland's work, while groundbreaking, also presents us with some serious challenges as we continue to explore the frontiers of AI. But I'm guessing his legacy extends beyond just the technical aspects, right?
You're absolutely right. Holland's influence goes beyond algorithms and systems. He also had a profound impact on how we view our own minds and the nature of intelligence itself.
Okay, I'm intrigued. Tell me more about that. So how did Holland's work, change the way we view our own minds?
Well, before Holland, a lot of research in psychology and cognitive science
Right.
kind of focused on breaking down mental processes into these neat little boxes, memory, attention, language, and so on.
Right.
But Holland's work on complex systems suggested a much more dynamic and interconnected view of the brain.
Okay, so instead of seeing the brain as a collection of separate modules, you're saying it's more like a network where everything is constantly interacting and influencing everything else.
Exactly. And that's a powerful idea because it suggests that intelligence isn't just about raw processing power or following a set of rules. It's about adaptability emergence and the ability to learn and change based on experience.
Yeah, that makes you think about how children learn They don't just download information like a computer.
Right.
They explore, they experiment, they make mistakes, and through that process, they develop their understanding of the world.
That's a great analogy. Holland's work really emphasizes the importance of learning and adaptation as key components of intelligence. And it has implications for how we think about AI as well.
So are you suggesting that we need to move away from AI systems that are purely rule-based and instead focus on creating systems that can learn and adapt more like humans do?
That's one of the exciting directions AI research is taking. We're seeing a lot of progress in areas like machine learning and reinforcement learning, which are inspired by the way humans and animals learn.
Right, those are the techniques behind things like self-driving cars and language models that can generate human-quality text. It sounds like Holland's ideas are still very much alive and well in the field of AI.
Absolutely. And as we develop these increasingly sophisticated AI systems, I think it's more important than ever to remember Holland's emphasis on responsibility and ethical considerations.
Okay, so let's talk about that. What specific ethical challenges do you see arising from the development of these complex adaptive AI systems?
Well, one of the biggest concerns is the issue of control as these systems become more autonomous and adaptable. How can we ensure that they remain aligned with human values and goals? How do we prevent them from developing behaviors or making decisions that could harm humans or society as a whole?
That's a pretty unsettling thought. It sounds like something out of a science fiction movie where the machines take over.
I understand the concern, but I think it's important to remember that AI systems are ultimately tools created by humans. And it's up to us to design and deploy them responsibly to ensure that they're used for good.
So what steps can we take to ensure that AI is developed and used ethically?
Well, one crucial step is to build transparency into these systems. We need to be able to understand how they work, how they make decisions, and what data they are using to learn. This will help us identify and mitigate potential biases or unintended consequences.
So it's not enough to just create a powerful AI system. We also need to be able to look under the hood and see what's going on.
Exactly. And we need to have open and honest conversations about the ethical implications of AI, involving not just researchers and developers, but also policymakers, ethicists, and the general public.
That's a great point. AI is going to impact all of us, so it's important that we all have a voice in shaping its development and use.
I completely agree. And I think Holland would wholeheartedly support that idea. He believed that as we create increasingly intelligent systems, we have a responsibility to use them wisely and for the benefit of humanity.
Well, we've covered a lot of ground in this deep dive, from genetic algorithms to complex systems to swarm intelligence. It's clear that John Henry Holland's work has had a profound impact on the field of AI and on our understanding of intelligence itself.
And his legacy continues to inspire researchers and thinkers today as we grapple with the challenges and opportunities of creating intelligent machines.
So as we wrap up this fascinating exploration of Holland's work, I'd like to leave you with one final thought. If intelligence can emerge from the interactions of simpler components, as Holland suggested, then where else might we find it? Could it be in the collective behavior of social networks, the intricate dance of ecosystems, or even in the evolution of cities?
That's a wonderful question to ponder, and it speaks to the enduring power of Holland's ideas. He challenged us to see the world differently, to recognize the potential for intelligence and adaptation in places we might never have imagined.
Thank you for joining us on this deep dive into the world of John Henry Holland. May his insights continue to spark our curiosity and guide us towards a future where AI and humanity thrive together.